Hello students, today we will be discussing about work. So let us first discuss that what is work. If I say about the work, then in our daily life we do many or much work which comprises physical as well as mental work also. But when it comes to physical work, it means that we are displacing or we are applying our energy to something that is making to move or that is making to do some work. But when we talk of a mental work, it means that we are utilizing our energy to do some work which is related to brain. So in physics, if we talk of a mental work, though it utilizes energy, though it makes us tired, but it is not considered as a work. In physics, work is only done when it is done in some physical senses, like some force is applied and it causes the displacement of an object. Then and only then we can say that work is done. In short, we can say that in work, we only consider physical work but not mental work. So first we will define what is work in physics. For that, I have considered a surface and on the surface I have taken a block of mass m. Now what I have done that I have applied a force F on this block in this direction, and due to application of this force, the block M is displaced to this part. And I said that the displacement of the block from this part to this part be S. So I can say that work done is dependent on the applied force as well as it is dependent on the displacement also. So now we can say that work is said to be done when force causes displacement. Now, in the above figure, I have drawn that shows that force is applied F, and due to that force applied F is the displacement S. So according to this formula, we can say that work is F into S. Now, it is not every time that the force applied is causing displacement in its own direction. It may be at some angle also. So, if I say that if I have a block like this of mass m, and this is the displacement direction of a body, and this is the direction of the force applied. So according to this figure, we can see that there is a angle between the applied force F and the displacement S. Let it be angle theta. Now the problem arises that how we can calculate work in such a situation when they both are inclined at some angle theta. Now we know that work is dependent on force and displacement, and force is vector quantity while the displacement is also vector quantity. So we know about the vector resolution also. Now let us take force in the direction of displacement, that is in this direction. So applied force capital F becomes F cos of theta, where theta is angle between F and S as figure represents, and due to that displacement is S. Let it be S. Now I want work. So as I discussed that force into displacement is work. So work equals to F cos theta multiplied by S, that can be written as Fs cos theta, which can also be stated as that work is a dot product of F and S. As we all know that the dot product always returns or always results in some scalar quantity. Hence, we conclude that work is a scalar quantity which is a dot product of force and displacement. Now, this is a mathematical formulation that we have discussed now. Now, let us discuss some cases regarding this. Presently, we are talking about the constant force. We are not taking the variable forces. Okay? Variable forces will be taken in the next turn, but presently we are talking only when the force applied is constant on a body. In that part only, I am taking different cases. Now, if I talk of cases, so let us discuss first case. If I talk of a first case, now in that case I have discussed that if theta becomes 0 degree, theta becomes 0 degree means that if I draw a block of mass m, now in this case if I draw a block of mass m and that applied the force in this direction and the body is displaced in the very same direction and its displacement is s. Now we can see that force and displacement are enacting in the same direction. When they are enacting in the same direction, it means the angle between them is of 0 degree. It implies that the value of theta is 0 degree. Now we can state that work is Fs cos theta. It means, which means that theta is 0. So F is cos 0. We all know cos 0 is 1. Hence work done is F into S. Now in this case, when they both are in the same direction, work is said to be maximum done. Hence we can say work done during this case, work done is maximum when force and displacement are in the same direction. So if it is given that they both are acting in the same direction, then we can also apply directly Fs. But never forget that theta also exists and there is a factor which affects it. Okay. Now let us discuss about second case. If I take second case, then in that case, if I consider that theta is 90 degree. Now, if I consider that theta is 90 degree, then it means this is the applied force F and this is the direction of displacement making at an angle of 90 degree. Now, here theta equals to 90 degree. Work is F S cos 90 degree. We all know that cos 90 is 0. So Fs into 0, hence work is 0. So we can say that when force and displacement are perpendicular to each other, then work said to be done is of 90 degree. Now we can take an example of this thing. For example, if I am having a tabletop. On this tabletop, I have a block of mass m. Now, I want that there is a gravity. We all know there is a gravity enacting in this direction. And due to some force, this block is moving in this direction, means displacement is in this direction. So we can all see that body is moving in the horizontal direction and the force of gravity is acting directly downwards. Hence, work done by the gravity will be 0 as the force of gravity and the displacement are at an angle of 90 degree. Hence, in this motion, work done by the gravity will be 0. So we can say now let us take another very good example of this. We all know about the motion of a particle. Now motion of a particle can be linear also as well as circular also. When we talk of a circular motion, we all know that a body is tracing a circular path. We all know that the body is tracing a circular path, let it be of radius somewhat r at center with center O. Now we all know that when a body is moving on a circular path, there is a force which enacts towards the center, let it be F, and here this F which is enacting towards the center of the circle is known as the centripetal force. F is force which is centripetal, and we all know that its formula is mv square by r. So we are not going to study about this, but we are going to study about the work done by this centripetal force. Now this force is enacting towards the center, but the body is displaced along the tangent in this motion. So we can say that at this point the direction of the displacement of a particle is this. That is represented by S. Now I want the work done by the centripetal force. Hence we can say that W, that is work done by centripetal force, is centripetal force into displacement into angle between them, that is theta. We know that theta between them is of 90 degree. Hence work done in this case also 0. So we can say that if a body is moving on a circular path, then work done by the centripetal force which is acting towards the center will be 0, because direction of the centripetal force is towards the center, but the displacement is along a tangent. So both of them are acting at an angle of 90 degree. Hence work done will be 0. So these were the some cases in which we were discussing that angle was 0 and which was making work to be 0. But if we say what are the other factors for the work to be 0, they are that force is 0 or the displacement is 0. For example, if I say that any person is sitting and doing the mental work, he is wasting his energy, he is having some pressure, he is having force, but the displacement of that person with respect to mental work is 0. So in that case also work done is 0.